Okay, we're on number 5, and number 5 says the coefficient of a second degree term of a quadratic equation is 1. So I'm going to write that down now. So I'm going to write down, it's going to be x squared. Let me go backwards a little bit. X squared plus bx plus c. And that's a quadratic equation. All right, so the coefficient of a second degree term of a quadratic equation is 1. So I'm going to put down equals 0. And again, a quadratic equation of the form ax squared plus bx plus c equals 0. Now they start talking about the roots, and I know there's some properties of roots that I need to understand. And I'm going to put the roots of a general quadratic equation down. And I'll certainly just want to write some things that you may or may not know, by the way. If I have a quadratic equation of this form over here, the roots of this thing, I'm going to say R1 would be minus b plus the square root of b squared minus 4ac over 2a. And the other root, R2, is going to be minus b minus the square root of b squared minus 4ac over 2a. Sorry about the sloppiness. So what's R1 plus R2? This is called the sum of the roots. Well, if I look at this over here, I get a denominator 2a. And what's nice about it, the roots disappear. And what do you get? You get minus 2b. So what do you go over here? Minus 2b over 2a would just be minus b over a. Right, that's the sum of the roots. I also want to do the product of the roots, R1 times R2. And if I did that, these are conjugates, by the way. On the bottom you'd get, 4a squared. And then, again, I'm trying to do the product of it, and I'm looking at it, and it's going to be, let's see, I'm going to say, let me write it down for you. So it's going to be minus b plus, I'm going to just put some nightmare over here, and then it's going to be minus b minus that nightmare over here. Well, it doesn't look too bad. What are you going to get over here? They're really just conjugates. You're going to get b squared over 4a squared. And then it's going to be minus that thing in the nightmare. What's the nightmare? It's b squared minus 4ac. All right, this works out pretty nicely, by the way. And you're going to get, 4ac over 4a squared. Well, the 4's disappear, and one of the a's disappear. You just get c over a. All right? So I'm going to start to erase this over here, and I want to write down what they're saying at this point. And I know the sum and the product of the roots now. All right, let me erase this business over here. I don't really need it anymore. And let's take a look at what I'm going to erase over here. So I'm going to say, maybe I should write this over here. If I have an equation, ax squared plus bx plus c equals 0, the roots R1 times R2, these are the roots, by the way, that's a product, would just be c over a. And the sum of those roots, R1 plus R2. And again, your teachers may or may not enforce this, but some people say, oh, you need to remember that. I don't think it's worth memorizing, by the way. I mean, if I were doing a lot of problems, I'd want to memorize it, right? So I think I did okay there. So let me see if I can, maybe read further on the problem, all right? By the way, someone says you're going to use this over here. Maybe, maybe not, all right? The coefficient of a second degree term of a quadratic equation is 1. If the constant term of the quadratic equation is increased by 1, let me do that now. And what are you going to get over there? If it's increased by 1, you're going to get x squared plus bx plus the constant term is increased by 1. So it's going to be c plus 1. Right, so it says the resulting roots would be equal. Well, if these roots are going to be equal over here, what I want to claim over here, I know something about the roots are equal. The discriminant would be 0. All right, so what's the discriminant? The discriminant would be a squared. In this case, it's 1, right? I'm sorry, I'm going too quick there. I realize that. I made a mistake already. Let me erase this over here. I said discriminant. And I put something down I do need to say. So the discriminant, I want to point out what I mean by that. The quadratic formula results in x equals minus b plus or minus b squared minus 4ac over 2a. The discriminant is b squared minus 4ac. So the discriminant would have to be 0. So it's going to be b squared minus 4 times the a, which is 1, and then the c, the constant, is going to be c plus 1. And that equals 0, for that to be true, by the way. So I'm kind of looking at that. I want to see if I can figure that out. And looking at, I'm going to say b squared is equal to 4 times c plus 1. Right, that really doesn't help me too much. Other than the fact I know something about b, by the way. All right, I'm going to go to the next one and read that for you. It says, if the constant term of the quadratic increased by 1, I did that, resulting roots of the quadratic equation are equal. But if the discriminant is diminished by 3, I'm sorry, I misspoke there. But if diminished by 3, the constant term, let me do that now. So x squared plus bx, the constant term is now diminished by 3. Let me read that again over as 0. If the constant term of the quadratic increased by 1, the roots of the resulting equation are equal. But if diminished by 3, the roots of the resulting equation is double the other. All right, let's put that down. So I'm going to write down, the roots of this thing over here. The roots of this thing, one root would be r, the other root would be 2r. All right? Okay, what do we do now? We got to start thinking through this over here. And what I'm going to do is, I got some formulas to write down, right? So I'm going to say, I'm going to use these product sum things, see if this helps me at all. Maybe it doesn't. So I'm going to say r times 2r would be equal to, and I'm looking this over here, it would be the c, that's a constant term, which is c minus 3 over the a. Well, the a is 1 in this case over here. So I'm going to say 2r squared is equal to c minus 3. All right? So let's keep going. Let's see if we can do the sum now. And that's going to be r plus 2r. Well, that's what it's going to be. It's going to be the opposite of the b. That's this over here. It's the opposite of the b over the a. Well, the a is just 1. So I got more information over here. And the question is, what do you do with that information? I guess I got to do something with it. I'm going to start thinking about it and looking at this thing. I know something about b squared, and I'm seeing something. This is 3r. And this was 2r squared. I got 3r and 2r squared now. Let's see if what I can do about that. Yeah, I'm going to start thinking and thinking about that. Well, I want to outline what I'm seeing that might be helpful to me. I see this. Whoops, sorry about that. I'll go backwards. This is kind of important to me. And the 2r squared is kind of important to me. I think that's okay. And the 3rb and minus b is sort of important to me. I'm seeing those three things over there. And the question is, I really got to figure out what the b and the c is in the problem. And I'll see if I can do that. And I'm looking at this thing over here, and I want to write down what, b squared looking at this guy over here. And I think I can do that, by the way. So I'm going to say b squared is equal to 9r squared. All right? And then the question is, do I know what r squared is? I think I do. It's right over here. So I'm going to write that down. I don't want the r, by the way. So I'm going to say b squared is equal to 9 times c minus 3 over 2. All right, let me look at that. And I notice that this up here might help me. I know what b squared is. What is it going to be? It's going to be 4 times c plus 1. That's what b squared is. And that's 9c minus 3 over 2. I think I can figure out c now. And if I know c, I probably could figure out b. So I'm going to say this, I'm going to multiply both sides by 2. This is going to be 8 c plus 1. This is going to be 9 c minus 3. All right, let's see if I can do this now. You can get 8c plus 8, 9c minus 27. All right, I'm getting close to getting c now. So this is going to be c. I subtracted 8c from both sides. I'm going to add 27 to both sides, and that would give you 35. all right? I know C is 35 now, all right? Unless I made a mistake. So the question is, can I figure out what B is? And I'm gonna do this up here, all right? So B squared is 4. And then what I get over here, I want to point out C is 35, right? So you get 35 plus 1. Boy, this is working out pretty nicely, by the way. So B squared is equal to 4 times 36. So what's B equal to? Plus or minus the square root of that. Well, the square root of 4 is 2, and the square root of 36 is 6. So you get plus or minus 12. So let's go back to the question. It says find the original quadratic equation. I think I just did. So let's write this down over here. It's going to be A, which is 1, so x squared. It's going to be plus or minus 12x plus 35 equals 0. There's 2 equations, by the way. All right? You can write down both if you want, by the way. You don't have to write down both. But the answer for that one over there would be x squared plus or minus 12x plus 35 is equal to 0. Thank you.